This is your Sir Orly again, and welcome back for another video lesson. For this video lesson, we will discuss Module 1, Describing Motion. For this module, you will be expected to describe the motion of an object in terms of distance and displacement, speed or velocity, and acceleration. Explain the object's motion using illustrations, and solve problems involving distance and displacement, speed and velocity, and acceleration. Now get ready and get your ballpen, notebook, science module, and your paper, and let's start. Now let's start with Lesson 1, Distance and Displacement. Motion is the change in position with respect to the reference point. An object is said to be moving when it has traveled a certain distance or displaced from point of reference. Motion can be described as the change in position for a particular time interval. If a body has changed its position, we can say that it has moved with respect to its original position. Thus, the original position serves as the reference point. An object may be moving with respect to another reference. For example, when you are inside a bus, you are not moving with respect to other passengers, but you are moving with respect to the ground. Motion can also be described by measuring the total length of the path traveled by the object and by measuring the distance between the initial position and the final position of the object. For example, a car ran 100 meters from point A to point B, then 50 meters from point B to point C, and another 100 meters from point C to point D. To solve the total length of path traveled, you can simply add the length of path from point A to point B, B to C, and C to D. So that's 100 meters plus 50 meters plus 100 meters. Therefore, the total length of path is equal to 250 meters. The length of the entire path that the object traveled is referred to distance. Based on the example a while ago, the total length of path is equal to 250 meters. This means that the distance traveled by the car is equal to 250 meters. Displacement is the shortest distance between the object's initial and final positions. To solve the displacement of the car, simply subtract the final position by the initial position. So we have the displacement is equal to final position minus the initial position. Therefore, distance is a scalar quantity. That means it has magnitude but no direction, while displacement is a vector quantity that has both magnitude and direction. Now let's try once more activity number 3, My Travel, on page 8. Directions. Trace the distance and displacement using the figure below. You are told to buy some foods in the market. You walk 12 meters east from home, 12 meters north, 6 meters west, 6 meters south, 6 meters west, and finally 8 meters north to reach the market. Question number 1. What is your total distance traveled? Adding all the quantity, you'll get 12 meters plus 12 meters plus 6 meters plus 6 meters plus 6 meters plus 8 meters equals 50 meters. Question number 2. Do you have a displacement? If you answered yes, well, you're correct, because the final position is different from the initial position. Question number 3. What is your displacement? As we can see in the illustration that the final position is at 16 and the initial position is at 2. Using the formula displacement is equal to final position minus initial position, 16 minus 2 is equal to 14. Therefore, the displacement is 14 meters north. Now let's move on to lesson number 2, speed and velocity. Speed is the rate of distance covered at a given time. We have the formula speed is equal to the distance traveled divided by the time covered. We can express speed in terms of miles per hour, kilometers per hour, and meters per second. Let's take for example the problem a while ago. Just yesterday, John and Mary were given assignments to record the measured distance and time spent in walking from their home to the school. John's home is 400 meters, while Mary is 200 meters away from the school. It took 400 seconds for John, while Mary needed 200 seconds to reach the school. Let's solve for Mary's speed first. We have the given distance is 200 meters and the time is 200 seconds. Using the formula speed is equal to distance over time, let's substitute the values. So we have 200 meters divided by time, which is 200 seconds. So dividing 200 meters by 200 seconds will get the speed of 1 meter per second. Now, let's move to John's speed. We have the given distance 400 meters and the time is 400 seconds. Using the formula speed is equal to distance over time, let's substitute the values. We have 400 meters for distance and 400 seconds for time. Dividing 400 meters by 400 seconds will get the speed of 1 meter per second. So we both have the speed of Mary and John. Since both have the same speed of 1 meter per second, therefore John is as fast as Mary. When a direction is associated with speed, it refers to the quantity known as velocity. Thus, velocity is speed with a given direction. So we have the formula distance is equal to displacement over time. As shown in the figure, the total distance from home to school is 3 kilometers, while the displacement is 2 kilometers east. Suppose you take 0.5 hour to travel from home to school. Use the information to solve for your average speed and velocity. Do we have the same answer? Good job! Remember, a change in velocity happens when there is a change in magnitude, direction of motion, both magnitude and direction. A moving object doesn't always have a constant speed or constant velocity. Sometimes when you jog or walk, you stop for a drink or say hi to your friends. In that instant, your speed changes, and that is called instantaneous speed. Whenever you ride a vehicle, not only the speed changes but also its direction. The vehicle may travel north, east, west, or south. That velocity in that instant time is called instantaneous velocity. A vehicle has a speedometer that tells you the speed at that instant or at that moment in time. As the vehicle travels along a busy street, you will notice that the speedometer may read 30 kilometers per hour. It may change speed to 60 kilometers per hour as it passes an open free highway and 0 when it stops. The figure shows the speedometer's readings of a car at 1 second interval within 4 seconds. As you can see, at time 0, the car is at rest. The car started to move at 1 second with a speed of 5 km per hour until 4 seconds the car speed is 50 km per hour. The changing motion of an object is called acceleration. The changing motion of an object is called acceleration. Acceleration is defined as the rate of change in the velocity. Thus, the formula acceleration is equal to the change in velocity divided by the change in time. Or in symbols, since change also means the difference between the final and the initial, therefore we have the formula acceleration is equal to final velocity minus initial velocity divided by final time minus initial time. Since the unit of velocity is meter per second, acceleration is expressed in meter per second per second. Oftentimes, the unit of acceleration is written as meter per second squared. Let's take, for example, the figure on page 16. The given are final velocity 50 km per hour, initial velocity 0 km per hour, final time 4 seconds, initial time 0 seconds. Using the formula acceleration is equal to final velocity minus initial velocity divided by final time minus initial time. Substituting the values from the given, we will get these. 50 minus 0 km per hour is equal to 50 km per hour. 4 seconds minus 0 seconds is equal to 4 seconds. Since the values cannot be divided because of different unit, we will convert first 50 kilometers per hour to meters per second. Therefore, 50 kilometers per hour is equal to 13.9 meters per second. Now, let's divide 13.9 divided by 4. Therefore, the acceleration is 3.47 meter per second. Motion with constant acceleration is not common in everyday life, like a passenger vehicle that moves along a highway. It can move at a constant velocity, changing velocity, or stop as it loads and unloads passengers. When a moving body decreases its velocity, it is said to decelerate. This negative acceleration is called deceleration. Deceleration is the opposite of acceleration, where the velocity of an object decreases. Let's have, for example, a passenger vehicle with a speed of 20 meters per second slowed down to 10 meters per second in 10 seconds. What is its acceleration? Therefore, the acceleration of a slowing car is equal to -1 meter per second squared. Let's try what you've learned. Did you get the correct answer? Good job! That's it for today. Thank you for watching and see you again next time. Bye!